Oh, there it goes. All right, now we're gonna do theorem 1010. All right, so what I'm gonna do now is I'm gonna draw a radius. Now it can be anywhere. It doesn't have to be straight up and down. I'm just doing it just for the ease of this video. Okay, so I'm gonna draw the radius right there. So I'll put an R for radius, and let's draw a tangent. But I'm not just gonna draw a tangent anywhere. I want to use this point right here. I want to draw a tangent to that point of tangency. Does that make sense? So I want to get a line, and now I don't want to come here because I'll never be able to hit that from that angle, will I? All right. I don't want to come here because I'll be able to hit it, but it's going to go through it. So I'm going to try to go about right in here. That should work. All right. Now look at that. Now I just drew a tangent to the point of tangency of that radius. Sarah, you see it. What do you think it forms? It's perpendicular, absolutely right. Okay, and that's what the theorem says it does. So if I draw, let's read the thing. It says, in a plane, it says a line is are we listening? Just pay attention, please. It says a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. All right, so this tangent is drawn to the point of tangency of this radius. You got it? So the radius comes to the circle, the tangent comes to the circle, hits it right there. That means, guess what we have? We have a right angle, which means they're perpendicular to each other. That's really going to help you out. That's going to help you figure out some stuff. So far in this lesson, we haven't really done any math yet. It's been all vocab, understanding what a tangent was and all that kind of stuff. Now we got our first theorem, so of course now we could probably do an example. So let's get rid of this and go to an example, and then we'll move on. Okay, let's do this real quick. What they're doing here is they're not asking to solve for anything. They're basically giving you all the information. What they're asking you is KL tangent to this circle, okay, at point L? Is it tangent? Well, you look at it and you say, well, sure, it looks tangent. Is it really?
No.
Let's do the numbers, okay? Let's see what we have. This length from here to here is 9. That's not the whole entire length. It's just 9. What do you think it is from here to right here?
8.
Okay, that would be 8. Why? Because it's the radius of the circle. Now check it out. What do I have? I've got a right triangle. This is the longest side, so that's 17 squared. This is the other two sides. I got 8 squared and 15 squared. Let's try to finish this up. This is 289. If you do the math here, that's 289. They're equal to each other. If they're equal to each other, what's true about this triangle? It's a right triangle, which means it's perpendicular, which means, guess what? KL is a tangent. Exactly right. And that's all they're asking. Is KL a tangent to the circle at the radius at that point right there? Is it? Yes, it is.